Hey guys, in this video we are going to go over page 12, solving equations graphically. So go ahead and pause the video, get this into your table of contents, and go ahead and turn to page 12, please. All right, let's go ahead and get started. So solving equations graphically. So we're going to talk about the number of solutions. So our solutions, when we solve it graphically, are when the two lines intersect. So I'm going to open up a Desmos graphing calculator. We're going to graph each set of our equations, and then we're going to look at what the graphs look like and what they can tell us about our solutions. So we're going to determine whether each of the following equations has 0 solution, 1 solution, or infinitely many solutions. So we're going to do the work for each one of these. So let's look at number 1. So we have 2 times n, which is 2n. 2 times negative 1, which is negative 2, and that's equal to 2n plus 2. So what I want to do is I want to graph the left side of the equation, so 2n minus 2, and the right side of the equation, 2n plus 2. So I'm going to go ahead and open up a Desmos graphing calculator, and every time we type something in a Desmos, we're going to change the variable to x. So I'm going to type in y equals 2x minus 2. So that was 2x minus 2 from the left side of the equation. Now I'm going to type in 2x plus 2 for the right side of the equation. And notice anytime we type it into Desmos, we always type in y equals in front of it. So it looks like this. So we notice that we have two parallel lines, which that means our lines never touch. So if the lines never touch, that means they never intersect, which means we have no solution. So our lines are parallel like this, which means there are no solutions. So for equation number 1, we're going to match 0 solutions with the first equation. And for each one, we're going to do the same thing. We're going to solve it by graphing. So we see here on the left, we have n plus 1. And then on the right, we have 2n minus n that we can combine like terms. And we get 1n plus 1. So just like we did for the last equation, we're going to type this into Desmos. We're going to do the left side of the equation and the right side of the equation. And we're going to make both of those x. So we're going to do it y equals x plus 1 for the left side of the equation, and y equals x plus 1 for the right side of the equation. And notice that my lines are overlapping. So whenever that happens, we have infinitely many solutions because every single point on that line is a solution, and it's a line on top of a line. Every single solution is the same. So this one we're going to match with infinitely many solutions, which means we know that the last one is going to be one solution. So let's see what that looks like. So 2n minus 1 on the left, and then n plus 2 on the right. So I didn't have any distributive property. I didn't have any like terms to combine, so this one was actually a little bit easier. So I'm going to do the left side of the equation, the right side of the equation. We're going to change our n's to our x's, and we're going to put a y equals in front of it. So we're going to type in y equals 2x minus 1. Y equals 2x minus 1. And then for the right side of the equation, we're going to type in y equals x plus 2. So notice that they intersect one time, and that's where it intersects, at the point 3, 5. So this one we already knew by process elimination. It was one solution, and this is what it looks like. It has a line intersecting the other line, and I'm going to put that point in red here. So this intersection point here is our solution, and that solution we saw on the last page, on the Desmos page, was 3, 5. So that's the point of my one solution. So for each of these on the assignment, you're going to type in the equation, the left side and the right side, into Desmos, and you're going to figure out which graph it looks like. If it's two parallel lines, they have no solution. If they intersect one time, they have one solution. And if it's a line overlapping another line, it's infinitely many solutions. So you'll just tell me how many solutions there are for each of the equations in the assignment. So if you need to, go ahead and pause the video, go back and finish page 12, and then I will give you the assignment that goes along with it.